Hey everyone, welcome back. So in this video, we are going to talk about VPC networks. Before we talk about VPC networks, we should know what a network is, right? I'm pretty sure all of you are familiar with the concept of a network. It's basically a collection of computers connected together through some sort of wires or wireless or whatever. An example would be the Wi-Fi network at our home, or a bunch of computers in a data center connected together through a switch. All of them are a network. But a VPC network means it's actually logical. It's created using software, and that is why the name VPC stands for Virtual Private Cloud. So the good thing about that is it gives us much more flexibility than actual physical networks, right? So a VPC can span across the globe. You can have machines part of the same VPC be on the opposite sides of the planet. Like you can have a virtual machine that's part of the same VPC network. One VM can be in Asia South and another VM can be in US East 1. This is an example of how exactly VPC networks would look in Google Cloud Platform. I would admit that it can be a little bit complicated if you are completely new to this. Don't worry about that. I will make it easier in the next slides. But in this one, you can see this is a single network. All of these VMs are in the same network. We can see there are two different regions here, US West 1 and US East 1. And there are different subnets for these different VMs. Essentially, these two are in two different regions. So that means they are in two different data centers, right? They are physically separated. Even then, with the use of VPC, we can make them look like be part of the same network. If you are interested in knowing how exactly Google made it possible, it is using a software called Andromeda. It's not exactly a software, but it's like a software-defined network, you could say. You should read about it. It's pretty interesting. But it's beyond our scope of this video, and so I'm gonna skip that. So why do we use a VPC? First of all, by default, we are using a VPC anyway. Like if we create a VM in Google Cloud Platform, it's part of the default network. When we have a VPC, that means all these virtual machines in that same VPC can talk to each other through the internal IP. That means no traffic leaves the network between them, and that means better performance, better security, and better segregation. Better segregation would mean like, let me show you an example. So let's say we have this network. It's a simple one, right? Not complicated as the one Google showed. Let's say I have created a VPC called production, and this is the production network, and these are all the VMs in this network. So I have an Nginx proxy, two web applications, and a database server. So now I have assigned IP address for each of them. So now we could say that they are all part of the same VPC, right? It doesn't matter which region any of them belongs to, but as long as they are part of the same network, they can talk to each other through this internal IP. That means in this Nginx configuration, I just have to specify the backends as these two IPs instead of having to specify their external IP addresses. Same goes for these databases. So that means from an outside perspective, we only need to allow access to this Nginx proxy. We only need to allow people from the internet to be able to connect to port number 80 and 443 to this server. And everything else we can close down. So that gives us a much better security by default. The other option would be without a VPC, all of them have an external IP address, and they talk to each other through the external IP. Then we have to manage firewalls for each and everything. We have to allow this server to talk to this one and this one to talk to this one, etc. A VPC makes it a lot easier and simpler and much more performant for us. And it's a lot cheaper too, because we are using their internal network itself. The bandwidth cost would be much cheaper than if we were to use internet traffic. We can talk about all of this all day, but it wouldn't make much sense until we actually do and create a network and see how exactly it works. Back in our Google Cloud Platform dashboard, I'm going to go to the VPC networks here. And we can see the default network is already present. If we take a look at, we can see that there is subnets created for each and every regions available. We'll talk about that in a moment. So I'm just going to go ahead and create a VPC network. So click on create VPC network. So the name of the VPC network is important because once you create it, you cannot change it. So I'm just going to go ahead and create it. It's like gonna name it production. Let's say if you have a single GCP project for all your applications in your company, that means you could create a production and a development network to segregate your production and development workloads. So that is one use case. So I'm just going to go ahead and create production. So the next thing that we need to do is we need to create subnets. So if you're completely new to the idea of subnets and networking, then I would strongly suggest you take some time off, spend some time and understand the basics of subnetting and IP addresses, because it's extremely important for you as a DevOps engineer or someone who is working with these kind of VPC networks and all, to have a basic understanding of IP subnetting. So under this subnet, you can see there are two different options. First one would be custom and the other one would be automatic. So if you click on automatic, you can see that GCP is going to create a subnet for us automatically. We don't have to create them manually. So it is creating a subnet for each and every region. Most of the time this automatic should be fine, but I'm just gonna go ahead and create custom anyway. That is because this gives us more flexibility on the subnet sizes and the resource planning basically. For more of like small companies and a smaller number of VMs, this doesn't make much difference. But as the scale grows and as you have more and more VMs and services part of your networks, it becomes more and more complicated. And at that time, you would need more control over the way the subnets are created. That is where the custom subnet creation mode comes into picture. Anyway, I'm just going to go ahead and create a subnet. Anyway, click on add subnet and name a subnet. I'm just gonna name subnet 1. No specific reason. I'm not very creative with names. So we have to choose the region. So the thing is, like, now that we are in the custom mode, we need to create a subnet for each and every region that we want to use. So for now, we are only gonna use Asia South 1, so it's fine. So the IP address range. The thing is, like, the IP address subnet range that we are creating for each subnet has to be unique in a VPC. It gets even more complicated that if you have two VPC networks and if you ever plan to have them connected together, then you would need to have each and every subnet be unique across both the networks. So it's always a good idea to keep track of your IP subnetting and make sure that you use a unique subnet for each and every one. So I'm gonna use 10.0.1.0/24. So this gives us 255 hosts in this subnet. You could go ahead and use this 192.168.0.0/24 also. So another option is private Google access. Set whether VMs in this subnet can access Google services without assigning external IP addresses. It's not relevant to us right now, so I'm just gonna give it as off. And here flow logs are for basically logging for the VPC network. We don't want that. It's just gonna add a lot of cost to it, and we are not gonna make use of it anyway. So I'm just gonna turn it off and done. You know what? I'm just gonna create another subnet 2, and I will use the US East one, and I will use 10./24. So here we have 10.0.1, and here we have 10.0.2. Done. So another option here is dynamic routing mode. So this is not really relevant to us right now, so I'm just going to leave it at the default option and click on create. Alright, look at that. Our first VPC network that we created. It only has two subnets in two different regions, US East 1 and Asia South 1. So now let's go ahead and create a few virtual machines and see how exactly it looks. I'm just going to go ahead and create this thing. I mean, obviously we are not going to install everything, but just to show you how exactly it looks. Okay, let's say Nginx proxy. And I'm going to create this in US East 1. E2 micro. So here under networking, I'm going to change this network from default to production. And it already automatically, assigned the subnet because, there is only one subnet in that region. So here we have an option to actually assign a static IP address for internal IP. That means we can reuse this the same way that we did with the external static IP address. For now, I'm not going to do that. Okay, done. Create. So let's go ahead and create our web app and the database too. Alright, so all the VMs are up and ready, and we can see the IP addresses that we just assigned: 10.2.2, 2.3, 2.4. They are all from the same subnet. So now let's try to log into this machine. Actually, before that, I wanted to add my SSH key. Instead of adding the SSH key to each and every VM, I just wanted to add it project-wide. So we just have to go to this SSH keys under the compute engine and add item. I'm just gonna add my key. So that way I don't have to add the SSH key individually to each of these VMs. Alright, so let's go ahead and copy the IP address and try to log in. Let's see what happens. We won't be able to connect to this machine at all. It's gonna time out. It is because we have not created any firewall rules for this machine, for this network at all. So if you go under VPC network and under firewall, so far we haven't created any firewall rules, but by default you can see that there were a bunch of firewall rules that was applied to the default network here. So now we need to talk about firewall rules because it's very important. So these are the firewall rules that were already part of this default network. Let's take a look at the first one: default allow HTTP. So if you open that, which network is this rule part of? The default network. The priority of this rule is 1000. That means if we have a rule that is of priority, let's say 900, then that will override this rule. Direction is ingress. That means this is indicating traffic coming into this network. Like in the case of web server, we will be accessing the web server, right? So that is ingress. Here's the important part: the target tags. So it says the target tags HTTP server. So what it means is, in GCP, when you create a VM, you can actually add a tag to that. Let me show you. So when we create an instance, under firewall option, it says add tags and firewall rules to allow specific network traffic, right? So when you click on this allow HTTP and allow HTTPS traffic and create it, what GCP gonna do is it's gonna add a tag. It's gonna add two tags to this instance. One would be HTTP server and the other one would be HTTPS server. Let me show you. Right, so if you open that instance we just created and scroll down here, network tags, HTTP server and HTTPS server. We can actually edit it and add our own network tags. For example, so just added a tag called DevOps from scratch and save it. So now when we create a new firewall rule, we can actually target these machines with this specific tag. That's what it does. So here the target tag is HTTP server. So that means this firewall rule is applicable to any VM with that specific tag. You can have unlimited number of VMs with the same tag. Okay, so the next thing would be source filters. IP ranges 0000/0. So this means to allow any IP addresses from any network or from the internet. So if you put 000/0 in source filter, then that means anyone can access on the port number 80 over the protocol TCP. So that's what this firewall rule does. So similarly, there is a firewall rule for TCP 443, and there is another firewall rule that is applied to all the instances in the network. It is also for the same IP range, and it's an icmp allow all. Basically, this is a firewall rule that allows anyone to ping our servers. But you can see all of this as for the default network, and there is nothing for our newly created production network. So by default, no machine can access anything. Basically, not even the same VPC can talk to each other. Even though we created this, these won't be able to talk to each other because there is no firewall rule allowing it. That is the default behavior. When we create a network and when we create instances, we need to actually manually add firewall rules and allow them to talk to each other, and that is the right way to do it. We don't want to just allow everyone to talk to each other, right? So first of all, we need to allow SSH traffic. So I'm going to create a firewall rule. So here, if you look at these firewall rule names, you can see these names all start with default. So that basically means the name of the network itself, right? So I'm also going to use that same convention and name my firewall rule as production allow SSH. So next we need to choose the network. That's going to be our production network. And direction of traffic, it is ingress because we want to be able to reach the servers, right? We need to allow targets. So there is two options here. There are three options here: all instances in the network, specified target tags, and specified service accounts. So for now, in this case, I'm just gonna go ahead and use all instances in the network. And source filter would be, again, there are three options: IP ranges, source tags, and service account. I'm gonna use IP ranges and 000/0. This is because I don't have a static IP address at home. So there is no way for me to give an IP address and tell GCP to allow that. I can temporarily give my current IP address, but then again, my ISP could change it anytime, and I would have to edit the rule again. But in a production environment, in a company network, do not do this. Do not allow all IP addresses to reach your servers over SSH. What you need to do is, if you are actually building a production network and if you are actually dealing with the company servers and all, what you need to do is you need to set up a VPN and then allow only from those VPN IP addresses. So what we need TCP protocol on port number 22. So I just give that and create. Alright, so our rule is in place now. We can use netcat to see if port number 22 is open for us. We use netcat-z v and then the IP address and then port number. And as you can see, it succeeded now. So we should be able to access all of our VMs over SSH now. Remember, we only created one rule for the production network, and that is only to allow SSH access. So let's go ahead and see what happens. I'm going to delete this instance one that I created to show the network tags. Okay, so first of all, let's go ahead and log into our Nginx server. I'm just going to go ahead and install Nginx anyway, so that I can demonstrate what exactly is happening by us adding more firewall rules. Okay, I'm going to log into the other two servers as well. Alright, so we are logged into all the servers, and ideally our web application would be having some sort of application running, right? I'm just going to go ahead and install Nginx just for the sake of demonstration. And I just need to show you how exactly it works when we try to talk to these servers over a port. Alright, so we have Nginx installed on all of them, and curl localhost should work in all of them. First of all, let's go ahead and try to ping one of the other servers, 2.3. Nothing happens because we have not allowed icmp packets to go through in this network at all. So let's go ahead and allow that. So that would be production allow icmp production network, and apply to all the instances. Source range would be which protocol? We only need icmp. Alright, so the rule is in place. Let's see. As you can see, our ping is started working, and now this Nginx server is able to reach that web application server over ICMP. We haven't given any other rules, right? So now let's say we need to be able to access this, whatever is running on the port number 80 here. We need to access it from this server to this one. For this use case, also we need to be able to access from here to this one, right? So how do we do that? So first of all, we need to add proper tags for each of these machines. We have 3 machines, and we need to add proper tags to all 3 of them. Let's go ahead and open Nginx proxy, and for the sake of simplicity, I'm just gonna give the same name as the tag. Same tag as the name. So edit and network tag, I will give Nginx proxy. Save. And for our web application, I'm just gonna give the tag as web app. Remember, we are not using this default firewall rule tags, but we are doing our own tags. Web app. Save. And last we have our database server. We're going to give the same tag. Let's say I'm going to give it database. Save. Okay, so now we have set the tags for all our servers. Now we just need to allow in the firewall rules, right? So here we can ping, but if we try to use curl and try to access this server, it will not work because, well, we haven't allowed it, right? What you could actually do is you could add a firewall rule that allows all the internal traffic. Here you can see default allow internal. This is for our default network that was present already. This is allowing all the all TCP, UDP, and icmp for this range. We can do this, and then don't have to worry about creating firewall rules for each and every service. But in my opinion, from the beginning itself, if we were to create firewall rules specifically for each and every service, that is the ideal way to do it. We should be giving least network access possible. Like if one server does not need access to another, then don't give it. That's it. That is why I'm making you guys do this, where we are creating specific firewall rules for specific reasons. Alright, so we have all our VMs set, and we have added the network tags for each of them. So Nginx proxy, web app, and database. So what needs access to what? First of all, we need the Nginx proxy to reach the web applications on port number 80. So let's create a rule for that. Production allow Nginx to web app. Alright, so that should be detailed enough name. Network production. Okay, so what is the target here? The target would be our web applications, right? Because that is where we need to allow access to. So this rule applies to this instances. So the target would be web app, and source filter would be, since we have tags added to the instances, we can use source tags. We have tags added to our Nginx proxy, right? So we just give Nginx proxy. So one thing to note here is that these target tags and source tags only work for internal IP addresses, and it only works over a VPC. So if you are trying to access them over the internet, over external IP, it will not work. Okay, so what do we need to allow? We need to allow specific protocol and ports, that is port number 80. TCP port number 80. That is it. We don't need to allow anything else. Okay, create. Alright, so the rules created, and now we can see that our Nginx proxy is able to access our web application on port number 80. Alright, so similarly, the web applications needs to be able to access this database server, right? But Nginx doesn't need to access, only these needs to access this one. So what I would suggest to you is you go ahead and create a firewall rule that will allow your web applications to reach to this thing. Maybe you can just install MySQL on this server and then use Netcat to connect to it and see if it works. In this video, we talked about VPC networks and firewall rules. I hope you have understood the core concepts and it made at least some sense to you. If you have any doubts, please leave a comment and I would be more than happy to help you. See you in the next one.